Thank you, Viv. And so this is the second to the last one. And because most of you have not been passing your exams that we've been giving, we're going to have Brother Brown repeat the series one more time so that you'll, no, not really. But we are going to have a certificate for you next week. If you come next week and win your certificate from the Christian Worldview Academy, signed by Dr. Joel Brown. And this will be very valuable someday when he is famous and world-renowned, and everybody will say, I remember when. Thank you for coming tonight. And are there any thoughts, questions? Lord, we pray you'd bless this evening's talk. We are so grateful for the Brown family and for Aaron and the children being here tonight. We pray you'd bless all that's done and be with Dr. Joel as he speaks in Christ's name. Amen. You're on, brother.
That brain layer and to lose it in place. But this kind of caught some attention recently because of this paper, which was published in 2016. Boring name, I mean, like most scientific papers. Cross-linking reveals laminin coiled foil architecture, but in this paper they were describing the structure of laminin, and here is the structure that they published. If you're slightly imaginative, you can imagine it's a cross. Now, the question is, how much should this be an argument that the Creator had this redemption plan because he embedded it in this laminin protein? I'm not using that argument. I don't want to rain on your parade. You want to use it. But I mean, it's not a complex shape. The cross is not. The fact that there are thousands of proteins out there in thousands of protein shapes, really no big deal that one of them sort of looks like a cross. Okay. Let's talk about that blue moon. I learned something new this week. So, the once in a blue moon actually comes from, there was a Krakatau volcano in Indonesia, and it, in 1883, erupted, killed some 30-some thousand people, a huge eruption, and when volcanoes erupt, they put particulate matter in the sky, ash and fine particles, and some of those particles are just the right size to filter red light out. So when you remove the red light from the moon, it looks bluish. And so there were several months where the moon looked blue. It actually dropped the temperature of the entire Earth 0.6 degrees Celsius from that volcanic eruption. And
the dust was for several years.
Sure, yeah. And and they called it a blue moon, and it was a very rare event. Now that has nothing to do, though, with what we now call a blue moon. It's just they stole the term, and what we now call a blue moon is the second full moon in a month. Okay. In the beginning, a biblical and scientific investigation of our past. My name is Joel Brown. My family's here tonight. I've got several of the kids out here. Some of them are in the nursery, and they'll all be joining us for the main service. We live right here in St. Louis, Missouri. I'm a high school science teacher by trade, and I got my PhD in molecular biology and genetics from Cornell University, studying embryonic development. I also spent some time studying Alzheimer's disease in fruit flies and spinal cord regeneration in zebrafish. I did that for 10 years, and then I went back into education. As a nature-based educator, I always like to start off by saying what's happening in nature now. Did you know yesterday was National Hummingbird Day?
No.
Yeah. I'm surprised your church doesn't celebrate that. It's the first Saturday of every September, so National Hummingbird Day. This is a picture I took this week. So we had a hummingbird event at Little Creek Nature Area where I work, but this had nothing to do with the event. We've been attracting the hummingbirds because we were going to have people feed the hummingbirds by hand at our event, and they did. It worked. It was a lot of fun. So we've been attracting the hummingbirds to my classroom, and I had the door open, which I frequently do, just leave the door open, and a hummingbird flew into the classroom. It's not unusual for a bird to fly into the classroom, but they always fly up to the windows, and birds are kind of dumb. They get stuck. They just cannot find their way out of the classroom. So I had to catch it with a net, and I got to hold, for the first time in my life, a hummingbird. And I feel like a gigantic hand holding that thing. It was like everything I could do to not crush it. This is our ruby-throated hummingbird, the only hummingbird here in eastern United States. Ruby-throated hummingbirds overwinter in Central America, and it is hard to see Missouri on that map. But you'll see as they migrate, they start to, you'll see this bright purple, which indicates a lot of prevalence. Boom, that bright purple, that is Missouri. So we're one of the highest populated areas for ruby-throated hummingbirds, especially down in the Ozarks. Anyways, that was free. That's what's happening out in nature right now. They're about to migrate back down south. Absolutely incredible creatures. So we are asking a simple question. We're looking at all these incredible things in nature, from the giant stars and nebulae and galaxies all the way down to the tiny stuff, the molecules, the DNA, the bacteria, the molecular motors, and yes, hummingbirds. And we're asking the question, where did this all come from? Today we're asking the same question, but it's going to look a little different because we're asking, where did this all come from? All of this incredible diversity. Well, if you turn to the very first verse of the very first chapter of the very first book of the Bible, you will find these words: in the beginning, God created. Right out of the gate, the first thing the Bible says, it declares God as creator. We're calling this worldview, in the beginning, God, or the biblical worldview. We're comparing the worldview to glasses. These are the lenses, the perspective that we are using to interpret the world around us. Everybody's wearing some pair of glasses. In the biblical worldview, I see the world around like those ruby-throated hummingbirds, and I see amazing design. I conclude there must be an amazing designer. I'm using two core beliefs. These are beliefs that I cannot formally test or prove in a mathematical sense or in a test tube. I believe there is a God, and you've seen some of the incredible evidence of Creator God. But I also believe that the Bible is God's Word. These are my core beliefs. However, there's another perspective out there. We're calling this in the beginning goo. You got to go all the way back to week 1, which is available on the YouTube live channel. Go back to week 1 to see where we get this from. And this is the evolutionary worldview. You could call it the secular worldview, the atheist worldview, humanist worldview. We're calling it the evolutionary worldview. They see the same amazing design. These people are not dumb. These are incredibly intelligent individuals. They're seeing the same design, but they're coming to a different conclusion. They conclude it must have come about by time and chance. There's one core belief that is being exercised. Their glasses that they're wearing. And that would be materialism. We like to sum this up with these 3 words. Materialism means no God allowed. These 2 different perspectives come to very different conclusions about the world around us. According to the biblical worldview, just a straightforward reading of Scripture, we would say that 6,000 years ago, about, give or take, God created everything. About 4,400 years ago, there was a flood. 2,000 years ago, Jesus was born and lived and died, and here we are today waiting for him to come back. In the evolutionary worldview, it looks very different. About 14 billion years ago was the origin of the universe with the Big Bang. 4.6 billion years ago, the Earth formed. About 3 billion years ago was the origin of life. That was what we focused on last time. And here we are today, 3 million years ago, the beginning of the origins of man to us now. Importantly, Not rocket science here, but an important point. Things that are different are not the same. And these are different. So we can go through all sorts of gymnastics to try to blend these two together, and people do go back to session 1 to see that in action. But they are different. That means something's wrong. One of them's wrong. And unfortunately, people tend to change the biblical worldview and say, the Bible must be wrong. We're doing the exact opposite. We're saying, wait, maybe there's something wrong with the evolutionary worldview. And you've seen that the last two sessions, we've demonstrated that. I'm not trying to prove the biblical worldview to you. It is inherently faith-based. What I am seeking to demonstrate is that the evolutionary worldview is also inherently faith-based. You will see incredible evidence that supports a creator, but I cannot formally and will not seek to formally prove that to you. These are the 3 pillars of the evolutionary worldview. The origin of the universe, you have to have matter before anything else can happen. The origin of life, you have to have life before it can evolve. And the origin of you, or all of those, the variety, the biodiversity that we see in this world. We have looked at the first 2. And while you're welcome to believe in the origin of the universe through random materialistic means and the origin of life through random materialistic means, I do not have enough faith to believe in that. You saw the enormous faith required to believe those with no God allowed. Now we're looking at number 3, Darwinian evolution today. This is classical evolution. Part 4, chutes or ladders. Let's go back in time to week number 1. Some of you were not here, so this question is going to look completely out of the blue. But we asked this interesting question. Do you believe in aliens? How many of you remember that question? Do you believe in aliens? Okay. And I had to emphasize that this seminar is not about aliens. Rather, what we meant when we say, do you believe in aliens? You should answer, what do you mean by aliens? Because there's a definition of alien that we would all accept readily. But then the little green guys, maybe not so much. Same thing now. What if somebody asks, do you believe in evolution? The single most important thing to get is, you must ask, what do you mean by evolution? Right. Don't let this scare you. There's part of evolution that's true. I'm going to demonstrate it to you today, tonight. Wow. I'm going to demonstrate it to you. There's part of evolution that's true, but then there's a part, which you've seen, that's purely faith-based. And you'll see both of those in action. And that's what brings us to our title, Chutes or Ladders. Now, I don't typically end with I'll give you my conclusion at the end, but I'm going to start with my conclusion so you can see how we get there. Here's what I mean when I say chutes or ladders. Have you ever played this board game? I'm not talking, there's probably an app out there that does it. No, I'm talking about the good old-fashioned board game, chutes and ladders is what it's called. We're calling it chutes or ladders. Here's what I'm talking about. Both the biblical and the evolutionary worldviews believe in change over time. You know what another word for change over time is? Evolution. So we both believe in change over time. Here's the key difference. In the biblical worldview, we believe God created a creation which was very good, and it's been changing for the worse ever since. It's been chutes all the way. In the evolutionary worldview, it's completely opposite. They believe that life started as this simplistic goo, and it's been ladders all the way. Therein lies the difference. Now, you still might be wondering, wait a second, do we really believe in change over time? And I told you I was going to prove it to you. Are you ready? I'm going to ask a simple question. Did God create chihuahuas? That's an interesting question to actually try to answer.
No way.
Maybe we should ask, would God create chihuahuas, right? I mean, absolutely. That's weird, right? So you're telling me if you went in a time machine back to the Garden of Eden, would there be a chihuahua there? No. If you went in a time machine back to Mount Ararat, as the animals are getting off the ark, would you have seen a chihuahua stepping off the ark? No. So where did the chihuahua come from? Okay, I'm going to read several portions of Genesis chapter 1. I want you to look for the word chihuahua. I'm going to read the white text. You read the yellow text. Here we go. And God said, let the earth bring forth grass, the herb yielding seed, and the fruit tree yielding fruit. And the earth brought forth grass, and, so I'm not there yet. And herb yielding seed, and the tree yielding fruit whose seed was in itself. And God created great whales and every living creature that moveth, which the waters brought forth abundantly. And every winged fowl. And God saw that it was good. And God said, let the earth bring forth the living creature, cattle and the creeping thing and beast of the earth. And God made the beast of the earth and cattle and everything that creepeth upon the earth. And God saw that it was good. Did you see the word chihuahua? No, of course not. But what did you see? After his kind, this thing kept jumping up. So without, the Bible is not a scientific textbook. It's not. God did not attempt to give us all the details. But what we can see is that God created living things, a whole bunch of them, and made them to reproduce after their kind. And because of that, because they are able to reproduce and adapt and vary, and because of all the genetic variation inside of it, here we are 6,000 years later, and you could get all of those dog breeds from some original created dog kind. In fact, the Chihuahua was first recognized as a breed by the American Kennel Club in 1904. Somebody somewhere had the bright idea to select for a dog that was small in stature, annoying yappy bark, and a larger-than-life personality, and they selected for a Chihuahua. The American Kennel Club currently recognizes 200 dog breeds. Not a single one of them existed in the Garden of Eden. Things do change over time. We can actually go a step further. If you took a gray wolf and bred it with a German Shepherd, gray wolf, Canis lupus, that's the scientific name, the species name, bred it with the dog Canis familiaris, you would get a wolf dog. Dogs can breed with wolves. That's because dogs came from wolves. And that's not a big surprise, right? In fact, the dogs and wolves are now so familiar, they consider dogs to be a subspecies of wolf now. It's just a domesticated wolf. So in principle, if you had the time and the resources and the enough kennels, you could start with a wolf and breed every one of those 200 dog species that we have today. Things do change over time. You can take this one step further. Here's a gray wolf, Canis lupus. Did you know that a gray wolf can breed with a coyote, Canis latrans? You see, they're both Canis, they're both part of the dog group, but a different species. And you get a coy wolf. It happens all the time in the wild. In fact, coyotes are very prolific. They can breed with a ton of the different dog species. In fact, there are approximately 8 different wolf species around the world. There's the red wolf, the gray wolf, there's the Ethiopian wolf, African wolf, there's the golden jackal. All these are up here. They're all different wolf species. It's very controversial which ones are actually unique species and whatnot. And guess what? They probably all descended from a single common ancestor, and it was a dog. Right? Nothing crazy about that. We would call this the dog kind. God created dog kind, and within that dog, there is the genetic variability to adapt to different environments around the world. But there is an obvious limit here. Okay, I need, raise your hand if you're under 10 or under. Oh, okay, I see that hand back there. And what is your name? I couldn't hear that. Still couldn't hear that. Corinne? Okay, Corinne. I have a question for you. Which one is not like the others? I have Canis familiaris, a dog. Canis lupus, a wolf. Canis latrans, and Musa acuminata. Which one is not like the others? Okay, there she got it. Let's give her a hand. So the point being, yes, these dogs can diverge into different dog organisms, but there's still an obvious difference between the dog kind and other kinds of animals. And here's the real kicker. You could start with a wolf and breed a Chihuahua. Could you start with a Chihuahua and breed a wolf? No. Because along the way, genetic variability has been lost. Genetic information has been lost. Do you see the shoots? Not the ladders. This is what we're talking about. Oh man, we could go on and on with examples. Here's the horse, Equus ferus, zebra, Equus burchellii, and the donkey, Equus asinus. All three different species. But did you know that a donkey can breed with a horse and produce a mule? They're able to interbreed. Now, mules themselves are sterile, but they're able to interbreed. We take that to mean that they're part of the same kind. Did you know you can take a zebra, cross it with a donkey, and you get a zonkey? So, although these are three different species, they're all part of the same horse kind. God created a horse with enough genetic variability to diverge into these different varieties. Let's look at the bears. Ursus americanus, the black bear. The polar bear, Ursus maritimus. And the grizzly bear, Ursus arctos horribilis, appropriately named. Did you know you can take a grizzly bear and a polar bear, cross them together, and you get a growler bear? I'm not kidding. Try this at home. Test me on this. This actually happens in the wild as well, where their ranges overlap. The polar bear can breed with the grizzly bear. We call them different species, but they interbreed, so really all of these varieties, it's just part of the same bear kind. And spoiler alert, do all humans look the same? No, there's enormous variety amongst humans as well. But Adam and Eve would have looked similar, and yet from them we have all this variety. One more. Okay, we've got Panthera burchellii, Panthera tigris, Panthera leo. Did you know you can take a leopard, cross it with a lion, and you get a lepun? Now these are very rare. Slightly more common example, you can take a lion, cross it with a tiger, and you get a liger. So again, some interesting varieties here. They can interbreed though, so they're likely all part of the same created panther or cat kind. But you will never get a kangarayan. Different kinds of animals, or a xyno, or a spog. As neat as it would be to have a sparrow dog cross. These are clearly different kinds of animals. So all that to say, cats have an enormous variety that could have descended from a single cat kind, created kind that God made. Bears, horses, all descended from a single horse, bear, cat ancestor. Things do change over time. However, this is what I would call little change, or adaptation, variation. The question, the much bigger question, is where did the different kinds of animals come from? Now, if you have a worldview that says no God allowed, you have a lot of explaining to do. So this is where Darwinian evolution comes in. So here's what we're talking about with Darwinian evolution. Last week we talked about the origin of that first simplest, quote unquote simplest, life form. in order for us to even have a conversation today, we have to give it to them that this could have formed, even though you saw last week that it's statistically impossible. So let's give it to them that this formed. How do you get to you? All right, so that brings us to Charles Darwin, a fateful voyage that he took in 1831 through 1836, traveled aboard the HMS Beagle. He was employed as the naturalist on board to study plants and wildlife that they come across in this voyage. They traveled around the world, and Charles Darwin was not dumb. He wasn't. I mean, he was a pretty smart fellow. He had the two skills that you need in order to be a good scientist. One of these was the skill of close observation. He just made very close observations of things. The other skill was note-taking. Like he kept very good records. So he went around, saw all this stuff, came back to his home in England, and he started writing. This is where he lived. Here's his office, and here's his famous book. Certainly one of the most famous books in modern history, On the Origin of Species by Means of Natural Selection. There's that species word. So here are some of the observations he made and the conclusions he came to. What you're going to see is he was seeing the same stuff we just saw. Like dogs, okay, they can interbreed. And then he took that to a different conclusion. Here's what he saw, one of the things, many things. Darwin counted 13 varieties of finches on the Galapagos Islands, some with thick beaks, some with skinny beaks. And he made this conclusion that they all probably came from a common ancestor, which was a finch. I have no problem with that. That's little change. That's adaptation, variation within a kind. No big deal. Here's a direct quote from his book. In regards to ducks and rabbits, I do not doubt that they all have descended from the common wild duck and rabbit. I do not doubt that either. I think he's absolutely right. What he's saying in graphical form, all the different breeds and species of ducks probably came from a duck. All the different breeds and species of rabbits probably came from a rabbit. Even this one. And this one. There's a rabbit in there. All right, no big deal. That's little change, variation within a kind. Another quote from his book, Mr. Blythe thinks that all the breeds of poultry have proceeded from the common wild Indian fowl. What he's saying is that all these chickens that we see, all the different variety, probably came from a common ancestor, and that was a chicken. No big deal. That's little change. But then, that is empirical, observable science. Now comes the leap of faith. Remember, that's kind of our point, is that this is faith-based. Here comes the leap of faith. Therefore, I should infer from analogy that probably all the organic beings which have ever lived on this earth have descended from some one primordial form. Now we're talking about big change. Now we're talking about this. We're not talking about variation or adaptation within dogs. We're talking about goo becoming you. Big change. And that's why this is so critical. When you hear, do you believe in evolution? It's a very loaded question. What do you mean by evolution? Because there are really these two types. There is what I'm calling little change evolution, and there's big change evolution. Little change evolution is variation within a kind. Big change is the theory of common descent, that you came from goo. Little change is the dogs, wolves, coyotes. Big change is bacteria to blue whales. Little change is scientific, it's observable. You can see this today as we breed different dog breeds. Big change is unscientific, it's never been observed. And here's the clincher. Little change and big change is a bit of a misnomer. Really, it's about the direction of the change. Little change is shoots, no new information. Big change is ladders, lots of new information required. Here's the problem. This is why this is so confusing to kids in school, to our general public. Both of these are called evolution. I mean, whether you agree with them both being called evolution or not, it'd be nice if they called them two different things, but both are called evolution. I call this the puzzle mania syndrome. Just out of curiosity, did anybody in here ever grow up seeing these puzzle mania magazines? Okay. So, when I was a kid, I was visiting my grandma's house once. And she had some of these Puzzle Mania magazines. And I'm going through, it's had mazes and crosswords, and I'm going through doing them. And there was a little postcard which you could tear out, and it had this little scratch off. And if you got 5 in a row, then you could send it in for a free Puzzle Mania magazine. So I scratched these off, and I got, would you believe it, 5 in a row. I now see in hindsight that was by design. So I got my 5 in a row, I showed my grandma, and she's like, hey, we'll send it in. So we sent it in. I went home and promptly forgot. So about a month later, I get a box in the mail. And inside this box were my 2 very own Puzzle Mania magazines and a Puzzle Mania tote bag. I was thrilled. And I enjoyed those and went on with life. The next month, another box arrived in the mail with another Puzzle Mania magazine, but this one had a bill associated with it. I'm a little kid, and I'm panicking, like, I don't have any money. I'm getting bills in the mail, and I'm only 10 years old. And so I'm panicking, and I did what you should not do. I hid it. I was so scared I didn't even tell my parents. And then the next month, another one came. And I'm so panicked, and my life for 2 or 3 months was just ruined by Puzzle Mania magazines arriving in the mail. What's the point? Here's the point. They said, hey, do you want 2 free magazines? I said, sure, I'll take that. And they sold me the whole subscription. Here's what happens in public schools every single day. They're gonna say, hey, you see dogs, wolves, coyotes, there's this variation. See those Galapagos finches, see this variation? That's evolution. And the kids say, okay, I'll buy that. And then they give them the whole subscription. That's what's happening here. Here's an example. I mean, this is National Geographic. Wolf to wolf. The evolution of dogs. Now, I wouldn't call that evolution. It's still a dog. That's just variation within a kind. But you see how complicated this gets? That's why this is the single most important understanding for us to have as we navigate this topic. So let's talk about that big change evolution. I want to see the big change, not the little change. And here's why you will never see the little change, or you will never see the big change in a textbook. Because there are 2 big problems with big change evolution. 2 reasons why it cannot and will not ever happen. First one, complexity. We're going to unpack this a little bit, but when you look around nature, there's incredible complexity. Just consider the human eye, the chloroplasts that are in plants that perform photosynthesis, a beetle, the bombardier beetle that shoots a cannon out of its rear end, the echolocation of bats, the feathers and flight of birds, placental development. There is an incredible number of things that have to happen just right at just the right time when that baby is born in order to survive birth and the spider webs. Now, this is all incredibly complex, but I want to add a word to this. When we're talking about complexity, the reason this is such a problem for big change evolution is because of this idea of irreducible complexity. Let me show you what I mean. I'm talking about a mousetrap. I have one with me. This is actually a rat trap. On a scale of 1 to 10, this is not that complex. It only has 5 basic parts. It's got the platform, it's got the little trip, it's got the spring, it's got the hammer, it's got the holding bar. It's only 5 parts. So it's not super complex, but it is what we call irreducibly complex. Now this part always makes me a little nervous, so hold your breath. Not super complex, but if you take all 5 of these parts, and if they are all here at the same time, that's important. If they're all here at the same time, then this performs a very simple but critical function. Along comes Mr. Mouse, and where are those worldview glasses when you need them? Okay, along comes Mr. Mouse and touches it. Dead Mr. Mouse. So here's why we call this irreducibly complex. Let's say that you had a complete trap, all 5 parts present at the same time. Let's say you caught 10 mice. Now let's say you lost one of those 5 parts. Does that mean now because you lost a part, now you might only catch 8 mice? How many mice would you catch? 0. But you just lost 1 part. You still have 4/5 of a trap. No, you need all 5 parts at the same time to perform the function. If one is gone, then it no longer works. This is irreducible complexity. This is a huge problem for big change evolution because something like your eye, which has all these interconnected operating parts, all of those parts had to be there at the same time to perform this function. Let me show you a great, perhaps my favorite example. This is not it, but this helps to illustrate the point. Did you know that a Boeing 747, which can fly, is made up of 600 million parts which can't fly? Think about that next time you're flying. Just don't think about it too hard. That's what we're talking about with irreducible complexity. All those parts together perform a function which none of them could perform on their own. Now let me introduce you to nature's mousetrap. I love this thing, the Venus flytrap. What an incredible design. Now, here's the Venus flytrap. It's got all these little traps on it. And these traps are, of course, excellent, natural, biodegradable bug control. Now, in order for this to function, several parts have to be there at the same time, just like the mousetrap. These same 5 parts have to be there. But this one actually has some bonus parts, too. The mousetrap, you have to put bait on it. The Venus flytrap comes with built-in bait. If you look very closely at the tips of their leaves, those red dots are actually cells that produce a nectar-like substance. Now, normally nectar is produced in a flower, but these produce it on these leaves. That's the bait. It has built-in bait. It also has a trigger, just like the mousetrap. If you look very closely, you can see it's got 6 of these little hairs. Those are triggers, because it just doesn't want to close for no reason, so something has to hit those triggers in order for it to close. It also has these red cells secrete a stomach acid. A plant with a stomach acid? See, what's the point of closing if you can't digest whatever you just closed? It has to have the cells that secrete the stomach acid to digest it. It has these cool little prism bars to help it close efficiently. And this is not to mention everything that's happened at the molecular level. This closure is caused by a pulse of calcium that gets transferred through the leaves and causes the leaf to bend in an instant. I mean, it's insane, the number of interconnected parts that have to work to make this function. I have a video coming up. Are you ready, Chris? I'm going to give you the countdown. 3, 2, 1, go. Perfect.
The Venus flytrap. Like the sundew, it makes itself very attractive, oozing nectar across the brim of each leaf. But any visiting insect had better watch out for these 6 tiny hairs. This fly has to tread carefully. If it strikes one hair, it can carry on feeding, but a timer has been set. A second strike in less than 20 seconds and the fly is doomed. An electrical impulse is triggered and the leaf snaps shut in just a fraction of a second. The tips lock together like prison bars. If the fly is very big or very small, it may just manage to escape. But most are trapped and die. Ten days later, the trap reopens. All that remains is a husk. The plant has finished its meal and resets itself for its next victim.
From a developmental biology perspective, this entire trap is self-assembled from the instructions in these tiny little packages. Those are the seeds from a Venus flytrap. That is incredible. You would be infinitely more likely of convincing me that this mousetrap assembled by chance than convincing me that that Venus flytrap arose by chance random mutations over time. It's irreducibly complex. All those parts have to be there at the same time. Darwin said if it could be demonstrated that any complex organ existed which could not possibly have been formed by numerous successive slight modifications, my theory would absolutely break down. He recognized this. That was 150 years ago. Now we know how complex, irreducibly complex these things are. That is a big problem for big change, but not the only one. Let me tell you, in my opinion, the bigger. Both of these stop it in its tracks, but this one's even bigger, and it sounds reminiscent of last time. Do you remember? Oh no, let me go back. Sorry about that. Thank you for your patience. There we go. Information. Information. Now, all of these things, the goo did not have them, so they had to come about by new information, lots and lots of new information. I'm going to show you just one very fun example of this. Let me introduce you to this information, the information to do this, and in order to highlight this, I brought a special guest. Ladies and gentlemen, let me introduce you to my the 8th family member. This is our Chilean rose-haired tarantula, Delilah is her name. I call her my oldest child. We will allow you to hold this after church. After church. Yeah. I'll pull her back out. Let me tell you about some of the incredible design features of this tarantula. It's got these tarsal claws, these little tiny claws that it can use to grab onto things. You can feel it when it's crawling on your hand. It's got these urticating hairs. It's these little tiny spikes on its back which it can brush off, and they don't kill you, but they are irritating. They cause a rash. So they're a defense mechanism. It's got an exoskeleton, an armor on its outside. And that armor does not grow like our skin grows. So as it gets bigger, it has to shed the armor. Here is what that looks like when it is shedding the armor. It looks like it's dead, because it flips over upside down, and then it pushes the old exoskeleton off, and underneath it's got a fresh, brand new exoskeleton. Who taught that tarantula how to do that? I mean, that's programmed into its DNA. That's information that the goo didn't have. That information had to come from someplace. It still looks kind of dead, but then it'll flip over, and voila, you have a growing tarantula. But the coolest thing that tarantulas and other spiders have, I would have to say, is the spinnerets. When you can look, some of its thread is coming out right now, some of it's silk. Tarantulas don't make webs, but they still spin silk. Silk is absolutely incredible. The elaborate structure of spider silk. Spider silk is one outstanding fibrous biomaterial which consists almost entirely of large proteins. Silk fibers have tensile strengths comparable to steel, and some silks are nearly as elastic as rubber on a weight-to-weight basis. In combining these two properties, silks reveal a toughness that is 2 to 3 times that of synthetic fibers like nylon or Kevlar. Spider silk is also antimicrobial, hypoallergenic, and completely biodegradable. Isn't that crazy? The Army's even talked about using it for body armor because of its strength and its light weight. But here's the incredible thing. This silk is a protein. It's a liquid protein which, when squeezed out of the spider's rear end, turns into something that's stronger than steel. Here's the sequence, the code of that protein. It's 3,779 letters long. Who programmed that? That is a huge issue. Where did all of this information come from? Let's give Delilah a hand. I'm going to put her away. Having a tarantula in our house was actually Miss Erin's idea. She forced it upon us, so I had to comply. So if you're stuck with a worldview that says no God allowed, where did the information come from? Well, let me tell you what they would say. Mutations. Yep. Mutations. Okay, so what happens if you take a turtle? That's a picture of a little baby box turtle we found at Little Creek. You mix it with some radioactive material, what do you get? Yes, okay, the Teenage Mutant Ninja Turtles. All right, so we know a thing or two about mutations. A mutation is simply a change in the genetic code. So here's genetic information, and we've changed one of the letters. That's a mutation. Mutations happen all the time. They happen. We know that. Here is every time you sit out in the sun, you're getting blasted full of mutations. If you go get an X-ray, those X-rays, that high energy beam, causes mutations. That's why they have you put the lead vest on, and then they say, "Excuse me while I step out of the room," because they don't want to get blasted full of mutations. According to science textbooks now, mutation is the ultimate source of genetic variation and thus makes evolution possible. That's where all this information came from, according to the evolutionary worldview. Here's Nature, which is the most prestigious scientific organization. Mutations are essential to evolution. Every genetic feature in every organism was initially the result of a mutation. They're calling that a protein which squirted out of the rear end of a spider turns into something stronger than steel, the result of 3,000 mutations. So what exactly are mutations capable of? This is empirical. We can test this. In 1926 and 27, this fellow here, Herman Mueller, used X-rays to shoot fruit flies full of mutations. Here's what a normal fruit fly looks like. He got fruit flies with stubby wings. He got fruit flies with darker bodies, with yellow bodies, with curly wings. These are all fruit flies that I worked with as well during my master's degree. With white eyes, with no eyes, and he got, whoa, what in the world is that? He got a fruit fly with, instead of antennae, it had legs growing out of its antennae. Here's what it looks like. There's the normal one on the left. Here's the fruit fly with legs growing out of its, where the antennae are supposed to be. That's wild. That's from mutations. During my PhD, we used mutations. This is 100 years later. We're still using mutations. We used mutations to study development. This is a normal mouse embryo on the left. Here's a mutant that we created in the lab. Here's how we created it. That's the one that I did my dissertation and my publication on, that mutation. Here's how we created it. We took a mouse.
You studied that.
Yes. We injected it with this chemical called ENU, ethyl nitrosourea. And that causes mutations. We crossed it with another mouse. The red stars there represent the mutations. And then we would look at the great-grandchildren, for reasons which I won't explain here. We would look at the great-grandchildren at the embryo stage and see if there were defects. And we found a host of defects. And we used that to study development. This is what our mouse room looks like. Just cages and cages full of mice to perform a high throughput screen like this.
Poor little mice.
We're not going there. We're not going there right now. So this is a normal mouse embryo. When you shoot it full of mutations, here is what we got. Are you ready? A highly advanced mouse. No! Nor did we expect that. Nor would you expect that, because we know what mutations do. This is not new science. Mutations delete information. Here's what we got. These are 6 of the about 16 mutants that we generated. They all have defects. Mutations mess up the genetic information. They don't improve it. So what are mutations capable of? They're capable of deleting information. They are capable of rearranging existing information. That's how that leg came growing out of the antenna. But they're not capable of this. Never have been, never will be, and that's a big problem because information, this is a PhD from MIT, information cannot be built up by mutations that lose it. A business can't make money by losing it a little at a time.
There goes farming.
So, do you know what I see? I see shoots, not ladders.
Right.
But if you believe in big change evolution, you need ladders, not shoots. This is a huge problem. And it's one that you're not going to hear in public school. They're not going to talk about that in the public school. The textbooks won't. But to me, this claim that all of this information is the result of chance random mutations over time is one of the most ridiculous claims ever put forth by modern science. You are welcome to believe that we are the result of chance random mutations over time, but I do not have enough faith to believe that.
Right.
So, where did all of the information come from? Where did that eyeball and the fly trap and the spider silk, where did the feathers and the flight and the chloroplasts and the photosynthesis, where did that information all come from? I'm so glad you asked. You see, if you turn to the very first verse of the very first chapter of the very first book of the Bible, you will find these words, "In the beginning, God created." And it's just as simple as that.
Amen.
Join us next week for part number 5. God or goo? The exciting conclusion. We'll wrap this all up. We've hit those 3 pillars, so now we're just going to land the plane. Come back next week.
747.
Hey, the time is 5:54. I don't think we have time for questions, but we're going to hang around for the service, and I would love to hear your questions. We've got a 5-minute break. Don't go far. We'll be back for... And we will pull Delilah back out after the service.
What does Delilah eat? Does she eat flies?
Crickets.